Hello everybody, welcome back to my channel, Brad's super fun science and research lectures and discussions. Today what we're going to do is we're going to review some leftovers, just some things I left out that I wanted to cover from the last episode, which was, I forget what it was called, but it'll be the episode previous to this one on my channel. But today we're going to cover the stuff we forgot last episode, and now we're going to work into formal physics. And so, to all the people out there in the team, we can do basically whatever we want. He said, I think we know enough about fundamental physics. Well, sure, but again, in the last episode, we just showed you the universe is expanding. So the applications and the actual theoretical proofing is so far out of your guys' league, you guys couldn't keep up, literally. And so you guys have your cool little engineering applications that are classified. Whoop-de-fucking-do, physics is not done and it never will be done. And so again, as we finished the last episode, we stated, we don't need to have a unifying theory. We just have a bunch of facts, and what I've demonstrated is a proofing method where you can have a complete proof, right? You can go back and watch my video where I addressed Gödel's incompleteness theorems. Again, I validated the first one and invalidated the second one. Made a whole independent episode on that. You can go watch it if you would like to. But I just want to kind of get into review the motivations of fundamental physics, what theory is supposed to accomplish, how theoretical physics doesn't really exist, meaning physics is empirical. It's all of the things around you. And as we covered last time, how we choose words, how those propagate throughout the species using our logic pyramid. And so we're going to cover some motivations, and this will definitely be a couple, again, you're just seeing these titles. I'm not making a new lecture series, but I'll be jumping around a bunch because the information's flowing extremely fast right now for me. So I'm just trying to I make these videos for you guys because the derivations for me, once I write it down, it's gone next. By the time I'm writing it down, I'm gone on to the next. And so what I wanted to say is we'll go over the motivation, we'll go over the leftovers, motivations, and then I'll just kind of talk about how I derive logic. Ontology of math is very archaic. And so again, when we're talking about our logic pyramid, you start at some top, timing is everything, it is what it is, any sort of general quote that you've heard a million times, it holds some intrinsic logic, it's cliche, but it's a cliche because it resonates with other people. And so if you say something or have the same experience, use the same words to describe that experience. And so you go from generality and you describe that with specificity, and when you describe something, when you go from an unknown to a known, you're establishing a proof. You're answering a why question. You're saying, here's the empirical physical reason as to why this statement, this structure of vibration that is sound, that is represented by letters, this sentence represents this physical phenomenon, and here is why it's true, and here is why it's new if you're doing a proof. Or at least a novel proof. And so, but it's very archaic, right? If you're sitting around cutting the shit up with your friends, guys or girls, you're not sitting there saying, oh, I believe Timmy is a faggot such that he has sucked 4 dicks. All right, you don't say such that. And when you're talking with your friend, you just say, hey, Timmy, you're a fucking faggot. And again, if you're watching this new, again, I'm a very direct person. I don't censor anything I say. I'm not religious. I'm not political. I'm just a scientist, and I just want to have a career and a family, which seems pretty center of the motivations of one in life. But to those confused about what I'm talking about, I'm an independent scientist. I've discovered a bunch of things going on behind the scenes with a ton of people. But I discovered independently. I discovered classified information that has been used for engineering applications that is withheld from the public, so they won't acknowledge my research work publicly, which is illegal in so many different fashions. It's disgusting, but I just keep pushing forward. But you just have all of these different things in different contexts in which you wouldn't use, right? You wouldn't say such that. But you ask someone to start developing a math proof, and they start using all of these words like such that, henceforth, moreover, furthermore. And as a actual example of everyday speech in which you do use it, right? Que tal in Spanish, right? It literally means what such. Tal is such, que is either what or that. And so when somebody says que tal as a form of what's up, it literally means what such. And then we say tal que, the natural response to que tal will be tal que, right? Such that, right? the super collider was spinning such that the collision produced the selectron, which it didn't because those things don't exist. But the point is, KTOL literally is kind of kind of archaic. I mean, it's kind of like a slang greeting today, but it's kind of like an archaic leftover of mathematical ontology because it's such a a formal like mathematical run over or just like segue. But also, if you learn any other foreign language or a language that you're not native to, the first things that are going to stand out to you is the prepositions. And so those are just some common language representations of different levels of specificity and generality as well as context. In the same way you change your vocabulary, the words you say around your parents, around your friends, or around your teachers, around just getting different levels of respect or professionalism or whatever the context, the physical scenario is. And so, logic demonstrates why something is true section. So I just kind of skipped over a section, but I'll just go over here, which was logic demonstrates why something is true. A math proof, and again, math to me is completely proof-based. It's nothing to do with calculation. That's the byproduct of a good proof. Again, we've already covered the structure of all sentences and subsequently of all equations. So it's kind of a huge step up from just calculating a third derivative or solving a differential equation. But it answers a why question. Calculation does not equal mathematics. Sentences are equations. Incomplete sentences are words without commands, did I would say, or without operation, right? In mathematics, you have addition, subtraction, division, exponentiation, logarithms, different things that say you do this to that thing. You do this operation to that basis, and you get this range, this set, this outcome space. Whatever branch of math you want to, whatever vocab you want to use for that. But just incomplete, and that's just a logical statement that stood out again, because I have all of these trivial theorems that they won't be very insightful to anybody else, and they're not really insightful to me. They're the product of insight, so I'm just sitting there just writing down all of these theorems and all of these pairs. And what a dichotomistic pair is to me is just two words. Let me just flip to it so you can see some. It's just anything in these brackets. When I put brackets around the words, those are just things that I intuitively know between two words are connected, and again on our logic pyramid, that are connected in our logic pyramid and will be in sequential order referenced in a proof further down the line. Because however long I live, the progression, time moves forward, time waits for nobody. But this is more logic than you guys can handle, but someday it will have some impact on somebody. But anyway, that is what a dichotomistic pair is. So when you see my presentation of my research, and again, my handwritten stuff, and when I type it on the internet, but logic explains what proof demonstrates, right? My pen is here. Why my pen is here is what the logic does, and the proof is that the pen is here. The evidence is actually, and in that example, we started with the evidence, but that's how you should do anything, as opposed to start with a language, or start with a theory, or start with an equation, and then try to produce something else. You have to start with fundamentally derived or understood insight from yourself, you, whoever you are, Johnny, Susan, Sally, Muhammad, whatever, the insight for new mathematics comes from personal insight derived from physics, meaning the physical reality of the world that you actually live in. Not in some textbook, because that textbook is written by a person who doesn't have the same insight or experience as you. We're all unique people, we all can provide, everybody knows something. And when you formalize that into a fundamental ontology, it becomes a mathematical proof. And deduction is derivative. Again, we all derive logic from the environment we were all born in. So that was kind of the leftover thing from the logic. Now motivations for physics. Okay, so to start off with our simple empirical fact, everything is connected, but nothing is touching. Literally, I'm not connected to my pen, right? We'll cover we'll cover discreteness and continuity, which is really what the motivation for the word quantum is, to quantize gravity. Why that really makes no sense. And we'll also discuss some history, but it's all kind of woven together. But, right, the pen can move independently of me. But the pen is made of atoms. The atoms are surrounded by electrons, an electron cloud. My finger is made of atoms, surrounded by electrons with an electron cloud. Negative times negative are repulses. And it's in a stable configuration, so that's why I'm not dissipating or it's not conducting electricity. That'd be pretty cool if you could conduct electricity, but your brain can. But point being is, independent systems, I'm what I would say touching my pen, but at the atomic level, at the lowest level you can measure, it's not actually, the electrons aren't actually touching, because it would require an infinite amount, you would have to approach an infinite amount of energy, which we'll discuss later why it should be momentum, to actually have that electron of this pen contact the electron of my finger. So that is our baseline, fundamental, physical, empirical fact. And I just have timing is everything, because again, just showing you these everyday phrases you hear, good vibes only, I just want to vibe. That resonates with me. Go turn on a sports game, in 2 seconds someone's going to talk about rhythm. I mean, it's all showing you, because we've already covered size, spatial size, meaning fractals, scale, things from the smallest to the biggest. Go look at a picture of an atom, or the picture of the atom, and the picture of the black hole. They're literally the same. Take a camera, put it out of focus, and then adjust the lens till it gets in focus, and you'll literally see going from discrete polygons for the shapes into the fluid continuous shapes we see. So really what we're going to do is kind of bound what we can model based on physical limits, right? It's very easy to say, we've covered, well, both were actually kind of easy, but right, the universe is measurably infinite, meaning also I have insight of how to develop universal progression for the shape of a universal shape, as a function of time. I'd have to, again, just, the insight comes to me pretty much just haphazardly, so I just have to put it all together. So that will come to me when it does. But what was I saying? Physical bounds. So we're going to define something called, I forget to, it's later on, again, I'm starting to rederive it now. Like literally right now in my head. But we'll get to it here in a second, but everything is connected, nothing is touching, and we have bounds where we can say, our range is unbounded because we can't measure past, XYZ, the observable universe is already defined, and at the lowest level, we can, we have a bound of like quarks coming together to form protons, or the electron, right? The electron is not a point particle, but we've developed enough proofing to say that size or shape at all sizes is scales. It's all proportional. Like you have a proportional triangle where you can calculate the angles and then use that as a ratio for a bigger triangle. We can absolutely do that for at the universal scale. And so right, so people in physics will say, we have the motivation to unify physics. And to unify physics, we're going to quantize gravity. And we're going to get to that, why that makes absolutely no sense. But really, in reality, again, put that picture of the logic pyramid in your head. Now, it comes to a point, and now imagine there's three-dimensional triangles everywhere, and they're all connected, and they're all points, and there's no center. And that's just an observable fact, and then you derive connections and relationships between them. And so you don't unify physics. You show how the linguistics relates to the language of linguistics, or logic relates to physical phenomenon, how you describe that process, and how those words relate. You're building out basically like the backing of a simple fact everybody already knows. Timing is everything. It is what it is. Good vibes only. Rhythm for fluid motion, or to limit inefficiency. And so we're going to, again, I'm getting to the final linguistic derivation, and when I'm at the end of a proof, just all of the logic is it's just coming in very, very, very fast. And so that's kind of what happened, but that's the fact, that's our motivation, is we're not unifying physics. We are showing that, again, Einstein was a person, Isaac Newton was a person, Leibniz was a person, Hooke was a person, Dirac, Pauli, all of these people were people. So they have some experience where they're looking at a physics experiment data or going about their lives. They're individuals processing information and then putting information back out into the universe through a paper, through a speech, through their presence, through whatever. And so you're really interacting with the individual. And obviously nobody knows everything. I don't know everything. You don't know everything. Nobody in the past knew everything. Nobody in the future is going to know everything. We're just building out, but everybody knows something. And then some people know more than some people else. And it's just building this repertoire or this knowledge where all facts are kind of on the same playing field. You're just increasing the specificity. And so